Hello students, welcome to e-learning. Today we are going to understand how to calculate center of gravity or centroid of a body or a plane section respectively. This is the continuation of unit 3 geometrical properties of sections. So problems on CG of irregular sections. Regular sections, we have understood the centroidal distances in the previous videos. Center of gravity, how to find the center of gravity of any body or any plane section. So first of all, to understand x bar, what is that x bar? X bar is nothing but the horizontal distance with respect to vertical axis, and y bar is nothing but vertical distance with respect to horizontal axis. Okay, so this x bar and y bar are nothing but the coordinates at last which they are going to tell us the location of the center of gravity. Okay, x coordinate and y coordinate. So for that particular x coordinate and y coordinate, we have two formulae to calculate x bar and y bar. X bar is calculated with a1 x1 plus a2 x2 plus a3 x3, okay, divided by total area of the section. Here it is. Okay, now see, a1 is nothing but the area of section 1, okay, and x1 is nothing but horizontal distance with respect to reference line, okay, vertical reference line of section 1. So a2 is area of section 2 and x2 is horizontal distance of section 2 with respect to reference line, plus area of section 3 is nothing but a3, and x3 is nothing but the horizontal distance of that particular section from the reference line, divided by the total area of the section. Okay, a1 plus a2 plus a3, all three sections are summed. So the sections may be infinite. Okay, infinite in the sense n number of sections may be there. So here in the formula, three sections are included, a1 a2 and a3. Okay, so similarly y bar is calculated. Okay, so continuation. So we'll take one problem there. See, you can find out there are two sections. It is in lamina of L section there with dimension 90 mm by 120 mm by 12 mm thickness. Okay, and they have divided the sections, L section, into two parts. The flange or you can say base of the L section is taken as section 1. Okay, so its area can be calculated, you can see now. Okay, so and the upper second section is the web section, you can say, or the another leg of the L section. So to find out the CG of this L section, first we have to take care of all the elements in the formula or all the values in the formula. So a1 x bar, how to find out x bar? So a1 x1 plus a2 x2 plus a3 x3. So we want to find out a1 first, right? So first we will try to understand a1 x1. So there are two sections, that is why the formula they have taken it as a1 x1 plus a2 x2 divided by a1 plus a2, right? So they have found out the area 1, that is 90 into 12. Okay, and they have put the value in that particular formula. X1 is taken with respect to leftmost leftmost reference line. So 90, from 0 to 90, the bottom leg. So there you can find out x1 is nothing but 90 divided by 2. Okay, so then later you can find out the second section. So A2 is area 2 can be taken as 120 is the height of second section. So minus what 12 mm thick of the leg, bottom leg. So it will be 108. 108 mm is the height of the second section and 12 mm thickness. So if you multiply 108 into 12, you are going to get area 2, and x2 is nothing but 12 by 2, that is nothing but thickness of the leg from its CG of second section. So divided by total area, that is section 1 and section 2, area 1 in area 1 plus area 2. Similarly, y bar is calculated area 1 into y1 plus a2 y2 divided by a1 plus a2. So a1 is already calculated 90 into 120 90 into 12, and a2 is 108 into 12. Y bar is nothing but now vertical distance from base. Okay, so first section, CG of first section is in the center of section 1. Okay, so that is 12 by 2. We know for that particular rectangular or square section, d by 2 or b by 2 is the centroidal distance. So y1 can be taken as 12 by 2 and y2 can be taken as 108, that is the height from this height, that is 108 divided by 2 plus the thickness of first section here. So 108 plus 108 divided by 2, 54 plus 12 is going to give you the y2 distance. Put the value and y bar is 38.3773. So both the values are calculated. X bar is 23.73 mm, y bar is 38.73 mm. So you can find out there now. You can now find out what is a1. A1 is 90 into 12. Then you can find out x1 is 90 by 2, that is 45 mm. That is nothing but from this reference line till the center of this section here. Okay, so that is nothing but x1. So next you can find out y1. Y1 for section 1 is from half of this thickness, that is 12 by 2, 6 mm. Next, for section 2, for this section 2, you are going to find out area 2, 120 into 12 directly they have taken. Actually 120 minus 12 into 12. Okay, this should be a little bit changed, 120 minus 12 into 12. Okay, because this thickness should be deducted here. For section 1, thickness should be deducted for this second section here. So x2 is nothing but again the horizontal distance of this section, that is half of this section, 12 by 2. Y2 is 12, this thickness, plus the half of this second section, that is nothing but 108 divided by 2, that is 66 mm. Now put all these values in the formula and you will get x bar as 23.73, y bar as 38.73, and so on. So this coordinates, if you mark, you are going to get this location G, capital G, which is nothing but the center of gravity of L section. So thank you students. For further notification and upcoming videos, subscribe the channel, like, share and comment. Thank you.